Hello. So as you may know, QGIS and GIS software in general can handle a vast number of data formats. And in this video, I'm going to very quickly cover a few of the most commonly used. Data is another word for information, right? And the information we use in GIS normally has a geographical aspect to it. We can generally split these up into vector and raster file types, though they can overlap. If you're unsure of the difference between a vector and a raster, please have a look at that video tutorial. So let's first have a look at some of the common vector file types. If you've seen the vector and raster video tutorial, you'll know that these will be mainly composed of points, lines, and polygons. The first file type that I'll cover are shapefiles, which you may have heard of. These are one of the most common and prevalent data formats by far. Here, I have a variety of shapefiles on screen, with all the data held in one folder on my computer. The shapefile format will actually appear on your computer as several different files, which may seem a little confusing. But essentially, each file contains a different type of information that QGIS needs to represent the spatial data. A shapefile folder will contain 3 mandatory data files. The first is a .shape file, which contains the feature geometries. The second is a .dbf file, such as you can see here. Essentially, it looks like a spreadsheet when it's opened up and contains the attributes of your features in database format. Again, if attribute data is a term you haven't come across, watch the vector and raster video tutorial where I discuss what it is. And the third type of file in a shapefile is a .shx file, which is the shape index file that essentially allows your computer to search for features faster. Note that if you ever want to share a shapefile with someone, you have to send the whole group of files. You can't just send the .shape file. Shapefiles can also include a file with a .prj suffix. These can be really useful, but they're not mandatory, and essentially they contain map projection information. That is the coordinate system that can be used for the map, and that is for the shapefile. If the shapefile doesn't have a .prj file, a pop-up dialog will ask you to choose a coordinate system when you import the other files into QGIS. Moving on, another file type is the GeoJSON. Like with other vector file types, these include points like addresses and locations, lines such as streets, roads and boundaries, and polygons like countries, buildings and parcels of land. Their simplicity and loading speed have made them very popular, and they are also fully compatible and easy to process with web technologies such as JavaScript. GeoJSONs are therefore a widely used data format for displaying vectors in web maps like Google Maps and Google Earth. Another major benefit is they come in a text format with the entire layer in one file, unlike with shapefiles. But it's also worth noting that the main disadvantage of GeoJSONs is that because they come in a text format, they can be relatively large files compared to other spatial vector layer formats like shapefiles. Another file type is the GML file, which stands for Geographic Markup Language. Again, as you can see here, it's very similar to the look of a shapefile. It's made up of points, lines, and polygons. In essence, a GML is an XML-like format for storing geographic data and associated content. It's a flexible way to create information formats and electronically share structured data via the internet. Therefore, they're often used for sharing geographic data with non-GIS users, as they can be easily delivered on the internet and they can be viewed in a number of free applications such as Google Earth and ArcGIS Explorer. You will probably also come across delimited text files, which you can load in QGIS as a layer. This is effectively tabular data, which is a very common and a widely used format in QGIS because it's simple and easily read. That is, data can be viewed and edited by yourself, even in a plain text editor like in Notepad. A delimited text file is an attribute table, but as it's in text format, each column is separated by a defined character, and each row is separated by a line break, and usually with the first row containing the column names. A common type of delimited text file is a .csv file, which stands for comma separated values. I have an example here in Notepad, and as you can see, and as the name suggests, for a CSV, each column within your attribute table has been separated by a comma, and at the top you can also see the column names. These data files will often contain geographic positional information as point coordinates in separate columns, such as latitude and longitude. And for this example, I have eastings and northings. In QGIS, this can quite easily be added in as a layer, but make sure to input the correct X and Y coordinates here, and this should appear as point data. Another file type that I don't have an example of here, but which you should watch out for, is the AutoCAD.dxf file, which stands for Drawing Exchange Format. This is a CAD legacy data format that allows the exchange of 2D vector data made in AutoCAD, that is points, lines and polygons, with other programs such as QGIS. Okay, so let's have a look at a couple of raster data formats. By far, one of the most commonly used rasters is a GeoTIFF, and for good reason, because the GeoTIFF formats allow georeferenced information to be embedded within a TIFF file. And a TIFF file, which is often associated with scanners, is essentially a raster graphic, so it's a digital image. And this can be black and white, grayscale, pseudo color, or true color. Usually in the case of GIS, the TIFF will be a scanned image of a map or an aerial photograph. So essentially, a GeoTIFF can hold further information within the TIFF graphic, and this can include map projections and coordinate systems. Essentially, anything that you would need to establish the exact spatial reference for the file. Commonly then, and as I've used here, you'll find that GeoTIFFs will be georeferenced raster maps or aerial photographs that can be displayed in GIS along with their coordinate systems. Next, and as discussed somewhat in the vector and raster concept video, we have the digital elevation model type, the .DEM file. A digital elevation model, otherwise known as a DEM, is the representation of continuous elevation values over a topographic surface, that is, a landscape. It's worth noting that DEM is often used as a generic term for digital surface models, or DSMs, and digital terrain models as well, or DTMs. A DEM is often represented as raster data, that is, as a grid of squares, also known as a height map. And finally, I should note that you will probably also come across image file formats that can be defined as raster graphics, such as .GIFs, which stand for Graphic Interchange Format, .JPEGs, which stand for Joint Photograph Experts Group. You also have Portable Network Graphics, or PNG files, and bitmaps, of course. These are raster graphics, but they can be assigned geographical information. Anyway, I hope that gives you a good overview of the different file types that you may come across while using GIS applications. Thank you.